Hey everyone, and welcome to another Explainer. Today, we are diving into a massive paradigm shift. And I mean something that is literally sending shockwaves through the entire world of physics right now. For the last 100 years or so, cosmological science has been built on this single, incredibly fundamental assumption. It's an idea that is so deeply embedded in absolutely every equation we use to understand the stars that even questioning it has always felt, well, kind of absurd. But what if we've been looking at the universe through the entirely wrong lens this whole time? What if the actual bedrock of modern astrophysics has a huge crack in it?
Seriously, just pause for a second and let that question sink in. What if the universe is built wrong? Or actually, scratch that. More accurately, what if the models we've been using to understand its architecture are just fundamentally flawed? Today, we're exploring a staggering new discovery that suggests exactly that. It's a finding that could totally rewrite our textbooks and, honestly, erase one of the greatest mysteries in modern science completely.
So to understand why this is such a big deal, we have to start right here, with something called the cosmological principle. This principle was basically born out of the Copernican revolution. You know, that realization that Earth isn't the center of the solar system, and later on, Edwin Hubble's realization that our galaxy isn't the center of the universe either. From all that, scientists deduced that we really don't hold a privileged spot in the cosmos. Therefore, if you zoom out far enough, way past individual galaxies and clusters, the universe should look exactly the same everywhere. It should just average out into this incredibly smooth, uniform, featureless expanse. Okay, let's dive into this, the Lambda CDM model. This is the standard cosmological model that grew directly out of that principle. And when we break down the composition of the universe based on this model, the numbers are just staggering. Everything we can actually see, the stars, the planets, you, me, that makes up just 5% of the universe. Another 27% is invisible dark matter. But that massive remaining chunk, 68% is dark energy. This is that mysterious repulsive force that scientists believe is driving the accelerating expansion of the universe. Now, this model has been incredibly successful at explaining cosmic history, for sure, but it relies entirely on the assumption that the universe is smooth.
Well, on June 24, 2026, a absolutely groundbreaking paper was published in the prestigious journal Nature. And its conclusion about the cosmological principle, it can basically be summed up in one single word: wrong. Not just, slightly miscalculated, not just needing a minor little tweak, fundamentally incorrect. The researchers argue that our absolute foundational assumption about a smooth, uniform universe, it simply doesn't hold up to their new data. No way.
Section 1. The Discovery, a cosmic bowl of spaghetti. So when researchers map the large-scale distribution of galaxies using these incredibly vast new datasets, they fully expected to find that smooth, uniform soup at the largest scales. But the reality is radically different. Even at these mind-boggling distances, galaxies are not just randomly distributed. Instead, they actually continue to align into enormous filaments. Imagine these gigantic cosmic strings of structure, stretching across distances that completely dwarf anything our standard model predicted. It's really less like a smooth, perfectly blended soup and much, much more like a massive cosmic bowl of spaghetti. Organized, structured, stringy. And just to give you a sense of the sheer gravity of this, consider what Subir Sarkar said. He's a leading cosmologist at the University of Oxford who reviewed the findings, though he wasn't involved in the study itself. He said, "This is serious." When a world-renowned physicist looks at data that directly contradicts the foundation of the standard model and delivers a blunt two-word verdict like that, yeah, we all need to pay attention.
Section 2. The Fallout. Erasing Dark Energy.
Now, what's really interesting about this is, if the cosmological principle falls, it doesn't just fall alone. It takes some absolutely massive concepts down with it. Remember that huge 68% chunk of our universe's composition we talked about a minute ago? Dark energy was inferred back in 1998 because we saw the universe expanding at an accelerating rate, and we needed some kind of invisible energy to explain why, assuming the universe was smooth, of course. But nobody has ever actually detected dark energy, and if this Nature paper is correct, that 68% of the universe, it might not exist at all.
The logic of how this works is actually super elegant. Step 1, you discard the cosmological principle. Step 2, you account for the actual real shape of the universe, these massive filaments of galaxies and the giant empty voids right between them. Step 3, you redo the math. Because if the universe is highly structured rather than uniform, the geometry itself completely changes how space expands. The physical shape of these cosmic strings and voids could naturally explain the accelerating expansion we observe. We wouldn't even need to invent an invisible dark energy to make the equations work.
Section 3. The physics community divides.
Now, of course, extraordinary claims require extraordinary evidence, right? And a claim this massive is facing some immediate, intense scrutiny. Skeptics have raised some entirely valid counterarguments that we need to look at. First, they warn that these massive filamentary structures could simply be statistical artifacts, basically noise in the data that looks like a pattern but might just dissolve under stricter analysis. Second, the Lambda CDM model hasn't survived for decades by pure accident. Previous surveys have validated it over and over. And third, to completely overthrow a century of wildly successful cosmology, skeptics argue we need definitive, undeniable evidence, not just one anomalous dataset.
But here is where the timing gets super fascinating. In May 2026, just before this Nature paper dropped, the largest survey of the world's leading physicists was released. The result? A striking lack of consensus. The physics community is currently deeply divided on fundamental questions regarding the nature of dark matter, dark energy, and the completeness of the standard cosmological model overall. So, the cracks in the foundation? They were already showing well before this new data even arrived.
Section 4. A stranger universe.
And this brilliantly illustrates how independent strands of science sometimes converge in just the most unexpected ways. Because right as cosmologists are mapping out this highly structured, stringy universe, theoretical physicists are stumbling into something remarkably similar on a totally different scale. In June 2026, the Nature paper showed a universe that is physically stringy and structured at macroscopic scales. But completely independently, a May 2026 paper out of Caltech found that by just starting with basic assumptions about how subatomic particles scatter, the core mathematical features of string theory spontaneously emerged. They didn't even assume string theory to start with. The math for the strings simply fell out of the basic physics.
It's wild, right? It leaves us looking at a universe that might be far stranger and honestly far more structured than the smooth equations of the last century ever led us to believe. We are shifting from this assumption of a featureless void filled with invisible dark energy to a reality of a vast, highly organized web of cosmic strings. So, I'm going to leave you with this question to ponder. If the universe is actually built this way, what other invisible truths are we entirely missing? Thanks so much for joining me on this explainer, and keep questioning the cosmos.